Use algebra to solve between 0 and 2 pi. We'll start with A. So we've seen a couple of equations already. We had one on our quiz with that had to use the hint, the sine squared plus cos squared equals 1, where you have two different trig functions in the same equation. So can you see in A that we have two different trig functions? We have sine and we have cosecant. And so we can't solve this right now because we have two different things. If we had the same thing, then we could use all of our algebra skills to solve it. So one of the things with these kind of equations that you're going to ask as a strategy, would there be a way to write this so that I only had one trig function? Could I use an identity to change something so that this equation was, say, all in sine? Yes. Can you see that you could change the cosecant to 1 over sine? So if I did that, okay, and I also want to point out, make sure that you see that this word says solve. It doesn't have prove in it. We don't have to set up a line and try to make both sides equal. Solve has an equal sign. We're trying to solve for x. So now, how do you solve this kind of equation? Does anyone know what kind of equation this is when it has a fraction like that? The x on the bottom, do you remember the name of it? Here, if I had 2x equals 3 plus 2 times 1 over x, how would you solve that? What strategies did you use in grade 11? Do you know what that kind of equation was called? Anybody have a name for this? It's a equation. That's close. Equation. Okay. Should I give you a hint? Rhymes with fractional. Rational. Oh, wow. You guys. Wouldn't it be nice if I could give hints like that on the test? Yeah. It's like, I don't remember what this is. Oh, it rhymes with 7th I over 6th. Okay. It's a rational equation. So when we're solving a rational equation with x on the bottom, what strategies did you have? What did you do? So you're saying, now do you have strategies for solving x to the negative 1 ones? Did anybody do this when did they write this? Was that helpful? You remember? No, you don't remember doing that? Do you know how to solve x to the minus 1 ones? Does that look more scary than this? I think it looks a little bit more scary. What did you do? And so you see, this is what math does. It teaches you something, right? How to solve quadratics, right? We know how to factor. We have a quadratic formula. You get those tools, and sure enough, we have quadratic equations now with sine, cos, and tan. We learned how to solve rational equations. So that skill set that you have for solving this then needs to be applied to here. Okay? What might you have done? Well, that fraction is what's causing a problem, right? How would you get rid of that x on the bottom? Multiply by x. So if we multiply this side by x, and we multiply this whole side by x, and this is usually a step you don't show, because you've learned that when you multiply the whole side by x, you multiply every term by x. But if you want to think about why that happens, okay? Because it's important to understand why things happen so that you do them in the future and you're like, okay, I feel confident in this. Okay? First of all, you know with an equation, if an equation's equal, if I multiply one side by 3 and the other side by 3, it's still going to be equal. That's the idea. What you do to one side of an equation, you do to the other, it will keep it equal. So when I multiply this side by x and this side by x, they're going to be equal. Now, what you often show is, well, here, when I multiply this side by x, Does it make sense that this would get distributed? Because you're multiplying the whole side by x. So what you often show is when you had this, and you multiply both sides by x, people often just do this. They multiply every term by x because they're doing that distribution without thinking about it. I want to make sure you understand where that comes from so that you're not just, oh, this is what we do, I have no idea why, blah, 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 blah. And that sometimes happens in math. Sometimes you just do things and you're like, I'm not quite sure why we're doing that. But it's important to understand why. Once you did this, you would get, well, this would become 2x squared. This would become 3x. And this x, the reason we did this was so that would simplify. And you're just left with 2. Great. We got rid of the x on the bottom. What kind of equation is it now? Sorry?
Oh, I was just going to ask. So when we multiply by equal 1 by sine x, is this going to be sine squared x or sine x?
It's going to be sine squared x. Yeah, so we're going to get back. But yeah, now this is a quadratic equation. And you know how to solve quadratic equations. You make one side equal to 0 and factor. So all of these different types of equations appear in the same question, and you have to think about, well, how have I solved those in the past? And I'll do those again. So now that we've thought about that a little bit, we can apply it to our question. We're dividing by sign. Don't like that. What can I do? I can multiply everything by sign. So I multiply this term by sign, this term by sign, and this term by sign, which will give me 2 sine squared x equals 3 sine x, and this one simplify. Perfect. And we just get plus 2. And now that it's a quadratic equation, we can move everything over to one side. And we're going to check if this factors nicely. First of all, with 2 sine squared, there's only one option for that. It would have to be 2 sine and sine. For the 2, well, there's only one option as far as multiplying is 1 times 2, but you could either put the 1 here and the 2 there, or the 2 there and the 1 there. So then you have to start thinking about the outside and the inside. Can you see that if you had chosen the 2 here and the 1 here, my outside is 2, my inside is 2. Does that ever make 3? No. So that won't work. So what we need to do is we need to put the 2 here and the 1 here to try that. Then my outside is 4, my inside is 1. Does that ever make 3? Yes. Now if I want a minus 3, can you see that you would need a minus 4 and a plus 1? So after you've done that check, quickly multiply that out in your head to make sure that it matches with what you had above. And we get our minus 2, we get our minus 3, we get our 2 sine squared. Everything works out well. So that means here sine x could equal a half, and here sine x could equal 2. It's a non-calculator question. Is this on our pie plate? What family? Yes, thank you. Negative a half. But it's still the same family, right? Pi over 6. Pi over 6. And then what quadrants are we going to look in? Quadrant 3 and quadrant 4. Sine x equals 2. Is that on our pie plate? No. How can we do this without our calculator? You can't? We need our calculator? Oh, it's not possible. Oh, when you said we can't do it, as in it's not possible, not that we can't do it without our calculator. Yes. If it was possible and you didn't have your calculator and it's not on your pie plate, there's nothing, you need a calculator then, because then you would need your calculator to find a reference angle. But any time that you get a value bigger than 1, you can just write not possible. Now I'm going to check, because we solved between 0 and 2 pi. Was this a general solution? Was this in a crazy domain? Our domain was 0 to 2 pi, which is what we did. So we're good, and we've solved this. So this first one, a recap. When you start off with an equation that has 2 different trig functions, then what you try to do is you try to get them into the same trig function. Part B, sine x equals cos x. This one you could do in 2 different ways. One, you could just think about your unit circle. Cos is the x-coordinate, sine is the y-coordinate. Are they ever equal? When? Pi over 4. So you could write pi over 4. Is there any other place that they're equal? 5 pi over 4. Because at pi over 4 you have like root 2 over 2, root 2 over 2. And at 5 pi over 4, in quadrant 3 you have negative root 2 over 2, negative root 2 over 2. Perfect. So there's the answer just by thinking about your pi plate. Just your unit circle and saying that's where they're equal. Is there a way in this one that you could rewrite this equation so it only had 1 trig function? So this is method number 2. If I divide both sides by cos, can you see that this equation would then look like this? And that makes tan. Oh, when is tan x equal to 1? What family? Pi over 4. What quadrants is it positive? Quadrant 1 and quadrant 3. Same answers. Different method. So when you have sine x equals cos x, you could change it to tan. Yes. I divided both sides by cos. And so cos divided by cos would be 1, and then I have sine divided by cos on the other side. Excellent. So question number 10 for this one.